7B, we're looking at confidence intervals for mean still, but this time small samples, okay? So what we did in 7A, we did a Z interval, and that only works if your sample size is at least 30, or you know the population standard deviation, okay? When neither of those things are true, we have to use something called a t distribution. And the reason for that is when we have a small sample size, one little outlier could really throw the data off. Okay, so what is a t distribution? It's a different curve. So if you remember from chapter or unit 5, when we drew that normal curve, the percentage, and we put the lines and put the percentages in there, the percentages were the same every single time. It was always 34, 13.5, 2.35, all those numbers. They were always the same. But when we have smaller sample size, we have to draw the curve different. So the curve for a sample size of 2 versus a sample size of 6 versus a sample size of 15, they all look slightly different, and those percentages are all slightly different until you get to around 30. And once you get to around 30, the t distribution basically looks exactly like the normal distribution. So that's why once we get to 30, we just say we don't need t anymore. We'll use normal distribution. Now, none of this is anything that you need to necessarily write down. It's just kind of background information for you to understand. Um, Less than 30 equals t, 30 or higher equals z. Okay, so let's look at our Desmos directions, okay? Going to be very similar. We're still going to be in that inference model in Desmos, but this time we're going to choose t-test, okay? And then we're going to enter our information just like before and get our confidence interval. So an example, we have 20 cars, the mean number of days, and standard deviation. And so we want a 99% confidence interval. Okay, so in Desmos, plus sign, inference again. This time we want the t-test. Okay, so last time we did z-test. This time we want t-test. Let me slide this over a little bit so you guys can see. All right, again, we're picking stats, and then we're going to enter in our information. So we had a random sample of 20 cars. They had a sample mean of 9.75, and they had a standard deviation of 2.39. Okay, create test, and then we want the confidence interval. All right, and so now I want a 99% interval, so I'm going to change that to 0.99. And there is my interval from 8.221 to 11.28. Okay, so the average number of days that the cars on the lot is somewhere between 8.2 and 11.28. Okay, sales rep tells you that the car you're looking at was delivered 4 days ago. He says you need to act fast and buy now because it will likely be gone tomorrow. Do I believe him? The answer is no, I do not believe him. Because the average number of days is somewhere between 8 and 11. Tomorrow would be 5 days. Okay, could the car be gone? Sure, but that would mean it was sold faster than average because usually they're there for somewhere between 8 and 11 days. So based on my interval, I'm going to say no, I do not believe him because 5 days is outside of my interval. Okay. All right. So now that we have these two different types where we have Z and T, you need to know how to figure out which distribution to use. Okay. So we have this little flow chart here, but I'm going to break it down. First thing we look at is sample size. If the sample size is greater than or equal to 30, so 30 or higher, use Z. You don't have to worry about anything else down here. If it's 30 or more, it's Z. Okay? If it is less than 30, okay, the next question you need to ask is it normal or approximately normal? Okay? In our class, that's looking for a statement in the problem. Okay? So if I look back at this question, assume the number of days are normally distributed. Okay, that means the answer to this question is yes. They told me it was normal. Okay, so we have to have that sentence somewhere in the question that tells you. It might say, sometimes it'll say normal, sometimes it'll say approximately normal. Either one of those is fine. If it doesn't say that phrase, so if my sample size is less than 30 and it doesn't tell me this, then I can't do anything. I can't make a confidence interval because mathematically it won't work. My sample size is too small, all right, and it's too, it's like wonky, it's skewed, it's not normal, okay? This next question, this is like a special case, okay? Is the standard deviation known? And this symbol is population standard deviation. So like in this question, this standard deviation of 2.39, that came from a sample of 20 cars. Okay, that's not what this is talking about. This is talking about knowing the standard deviation for the whole population. Okay, in that case, we could use a z-interval, but if I know the population standard deviation, I probably know the population mean, and I don't need to do a confidence interval at all. So this is like a weird, random scenario that very, very rarely happens. Most of the time, the answer is no, and so we would use a t-interval. So general rule, if it's 30 or higher, z. If it's less than 30, t, but you have to make sure this sentence is there. Is it normal or approximately normal? Is that sentence, that phrase somewhere in the question that says it's normal or approximately normal? Okay, because otherwise we can't do anything. All right, so we'll look at an example. We have a random sample of 25 newly constructed houses. That means I can't use z. All right, they gave me the mean and the standard deviation. Assuming construction costs are normally distributed. So there's our magic word. Whoops. There's our magic phrase. Okay, we don't know the population standard deviation because we almost never do. So for this question, I would use a t interval. All right, and that is it for 7b.